Hello students, I am Sapna Makan from Bal Bharati Public School Rohini. Today I am going to tell you a day in the life of Shruti and how she discovered maths around her. It was summer break. Shruti was longing for it from so many days. Those fun-filled days are back, she said to herself. But as all summer breaks are, they are loaded with homework. This time was no different. Only because the teacher had told them to find existing mathematical concepts that they see every day around them. Shruti had heard about so many things. Maths is everywhere, maths is fun. But although it seemed so nice to ears, finding actually something related to maths was not a piece of cake. She did not know where to begin with. So she decided to carry a small diary and note down whatever related to maths came up. While she was deciding how to go about the project, her younger brother was playing with a molding clay. He made a big ball of clay and rolled it on the floor. Then he made smaller balls out of that big ball. Shruti could see that a bigger sphere has been converted to several smaller spheres. Her younger brother used the same molding clay to make a pillar, then a cube, and then he tried his hand at making a cone. So on and on he went. Shruti noted all this in her diary. Later in the day, the family went to the market. They went to the ice cream parlor. The different flavors were displayed in cylindrical tubs. Shruti decided to have strawberry ice cream. While Shruti had the ice cream in a cone, her brother took it in a cylindrical shaped cup. Again she noticed that the shapes were changing. Her friends came to her house in the evening. Mother served them milkshake in a jug. The milkshake was in a cylindrical jug. Shruti poured the milkshake into glasses. The milkshake was not cold, so mother gave them some ice cubes. Everyone was busy talking, only to find out later that the ice cubes have melted and water was there in the shape of the bowl. Finally, it was dinner time. There was curry on the dining table in a large hemispherical bowl, which she served into 6 smaller hemispherical bowls. The curry was transferred from the larger bowl to smaller bowls. When she had served curry to everyone, she saw there was no curry left in the larger bowl, although the smaller bowls were completely filled. At the end of the day, Shruti recalled what she had observed throughout the day. Different shapes like sphere, cylinder, and cone were made from the same molding clay. The ice cream from a cylindrical tub was served in a cone and a cup. Milkshake was poured from a cylindrical jug to glasses. Cubes melted to take the shape of the container. The curry was served from a large hemispherical bowl to smaller hemispherical bowls. The beauty of the whole process was that at every stage, shapes were changing, but the volume remained constant. Suddenly, something came to Shruti's mind. She realized that she was witnessing the conversion of solids from one shape to another. You know, children, that each and every solid occupies some volume. When you convert one solid shape to another, its volume remains the same, no matter how different the new shape is. Hence, when you convert one solid shape to another, all you need to remember is that the volume of the original as well as the new solid remains the same. Hello listeners, I am Sapna Makan from Bal Bharati Public School, Rohini. Good morning students, welcome to class 10th.
Good morning, Mom.
Why is everyone smiling?
Mom, we are very happy because India won the cricket match yesterday. The team won the toss and they decided to bat.
How was it decided that which team will get to bat first?
Mom, it was decided by tossing a coin.
Do you know why is tossing a coin considered to be a fair way of deciding which team should get to bat?
Because when we toss a coin, there are only two possibilities head or tail.
So the probability of winning a toss is 50% or 1 by 2.
Mom, why is it 1 by 2?
To understand this, let's rewind to class 9th. You have done questions like in 1000 tosses of coin, there are 545 times that heads comes up. Though this is not 50% exactly, we will perform a small experiment to understand it better. Now one of you run to maths lab and get the coin box.
Mom, I've got the coin box.
There are 100 coins of 1 rupee in it. Listeners, you can also perform this experiment with us, though your results might vary a little. Now shake the coins and lay them flat on the table and count the number of heads.
Mom, there are 42 heads.
We will repeat it 4 more times.
Yes, Mom.
How many heads came up each time?
Mom, heads came up 42 times, 51 times, 54 times, 49 times and 57 times. But Mom, this is not exactly 50% of times.
You are right. Now let us know some facts. There is a law known as Law of Large Numbers given by Jacob Bernoulli in 1713. This law states that as the number of trials increase, the experimental probability will get closer and closer to the theoretical probability. To see this, the number of trials should be sufficiently large. But every time it is not possible to hold a large number of trials. Sometimes repeating an event can be very expensive and not feasible. Say, what is the probability of the failure of the satellite? It is not possible for any country to launch 100 satellites for the sake of trials. In such cases, we have to rely on theoretical probability. Let us closely look at what is the difference between the two types of probabilities. Experimental probability is what actually happens when we try out an experiment, whereas theoretical probability is what we expect to happen in an experiment, or we call it an event in theoretical probability. The probability is still calculated the same way, using the number of possible ways an outcome can occur divided by the total number of outcomes. To understand this better, let us take another example. Suppose there are 3 friends, Hiya, Divyansh and Yukta, and each tosses a coin individually. Hiya had a head 20 times, so the probability of getting a head is 20 upon 50 equal to 0.4. Divyansh had a head 26 times, so the probability of getting a head is 26 by 50, that is equal to 0.52. Yukta had a head 28 times, so the probability of getting a head is 28 upon 50, that is equal to 0.56. Let us compare the results with the theoretical probability, which should be 25 heads, or 25 upon 50, which is equal to 0.5. To know this better, plot a double bar graph of each experiment with the theoretical probability to compare the results. You will observe that the two bars are almost of the same height in each of the cases. So, experimental probability tends to theoretical probability. Precisely, the formula for calculating the two probabilities are: in experimental probability, probability of an event is equal to number of times event occurs upon total number of trials, and in theoretical probability, probability of an event is equal to number of favorable outcomes upon total number of possible outcomes. We take another example. If a die is rolled 6,000 times and the number 5 occurs 990 times, then the experimental probability shows that 5 shows up on the dice is 990 upon 6,000, which is equal to 0.165. The theoretical probability that the number 5 shows up on a die when rolled is equal to 1 upon 6, which is equal to 0.167. This is because of the 6 possible outcomes, dice showing 1, 2, 3, 4, 5 and 6. Only one outcome, that is dice showing 5, is favorable. Now 0.165 and 0.167 are very close to each other. We can sum it up in the following way. Experimental probability calculates the number of times an event did happen, as you have seen by conducting experiments using coins, while theoretical probability calculates the number of times an event can happen mathematically. So, in experimental probability, you used your actual experience, while in theoretical probability, you use your knowledge.